So we are doing graphing and intercepts in this class. It's not made to be like an algebra type class, so I try to limit as much algebra as I possibly can. Honestly, this is probably your least fun section for y'all to do, but let's do it and get it over with. So graphing and intercepts. So a standard form is the ax plus by equals c. That's called standard form. We won't use that much. What we use is the slope-intercept form. The y equals mx plus b, you all have heard that before, but just to go over it, because anytime you get an equation in math or science, you should write down what each variable means, okay? That way when you go to do word problems and things like that, it makes it so much easier. So y equals mx plus b. M is my slope. I was going to ask y'all if you remember rise or run, but it's right there on there. By the way, I know I talk fast, so if you need me to slow down or something like that, let me know. Or should go back and show you something, like scroll back up, I can. So M is my slope. That's rise over run. That's how much it goes up or down. And then the bottom number tells you how much it goes to the right. If it's positive, it goes up. If it's negative, it goes down. But the bottom number always tells you to go to the right. We read left to right, so we always want to work from left to right to make sure this works out, and it makes it so much easier. So if it's positive, you go up. Negative, you go down. How much ever the numerator is, and then the denominators tells you how much you go to the right. The b is my y-intercept. That's the number not by the x. That's my y-intercept. To algebraically solve the y-intercept, which we will do today, you make x be 0. Okay, I know I tried, and I just said we're not doing much algebra, and then I just said algebraically, but you make x be 0 because that's where you're at on the y-axis. So x is 0 when you're at the y-intercept. This is what our starting point is, okay? So our starting point, if you're taking this to try to apply it to real life, this is like where you start in real life. So like if you have a finance thing and it's 0 profits and you're trying to figure out how much manufacturing costs, or you're doing like charting weight loss and calories. Like if you burn 0 calories, how much weight loss will you have? Like, so it's your starting point. So you start there and then you do what your slope says, which is your rate of change. Now, the M and the B, y'all have heard a lot about. The X and the Y are the things that nobody ever defines, but that X and the Y are any point on the line. The line is made up of an infinite amount of points, so that X and Y are the points on the line. It's called an ordered pair. So the first topic is just determining if an ordered pair is a solution. Okay, so pretty easy to start here. So you got 1, 3. My X is the 1. My Y is the 3. So I plug in a 1 for my X and a 3 for my Y, and I'm seeing, does that equal 5 when I plug that into the equation? So this is just 2 plus 3. And that does equal 5. So yes, that means that this point 1, 3, x1, y3, is on the line. Okay, because that was a solution. The next one is the same idea. I have a 4, negative 2. Let's keep doing that. X equals 4, y equals negative 2. So I plug that in. I get 3 times 4. And 2 times negative 2. Okay, so you plug the 4 into the x, the negative 2 into the y. This is 12. Negative 2 times negative 2 would be positive 4. So this would be 16 equals 6. Well, 16 does not equal 6, so no, that point would not be on the line. Terrible noise, sorry. All right, the next one is finding a solution. This one's not hard, but it does mess you up a little bit because it's just the way it works. This one, we're trying to figure out what point could be on this line. So we're trying to figure out any point that could be on this line. So what we want to do is pick any x that we want and plug it in to figure out what y is, or pick any y that we want and figure out what x is. So somebody yell out an x, any number. 3, did I say 3? Okay. So x equals 3. So you can pick anything you want here. So if I plug in 3 for my x, I get y equals 6 plus 1, y equals 7. So the point 3, 7 is on the line. So we like figure out what the x is. The x like locates and then it tells us what the y is. We just pick an x and it will tell us what our y is. All right, the next one, same thing. Let's plug in a y this time just to see. Again, you can pick an x or a y. So this time we're going to pick a y and figure out what the x is. So somebody yell out a y. 2, okay? So you can pick anything you want. It's always hard. These problems are always hard when you get to pick anything you want. Because you look at the learning page and you don't realize that you can just pick any number you want. So when I do this one, 4x minus 2 equals 3. So I do have to do a little bit of algebra on this one. To solve for x, I'm going to add 2 to both sides. And I get 4x equals 5. And then divide by 4. X equals 5/4. That is okay that we got a fraction. When that will be on our line. When y equals 2, x equals 5/4. All right, next we actually move into graphing. So these are all going to start out into the form y equals mx plus b. So if I have y equals 3x, that is like y equals mx plus b. So my slope is always the number in front of x. My slope here is going to be m equals 3, okay? Because that's the one right next to the x. So I'm always going to write my slope as a fraction because that's rise over run. So we got to know what our fraction is. So we change that to 3/1. When you do the slope, anytime you look at the slope and you see it, like just go ahead and think about what it means. 3/1 would be up 3 to the right 1. Up 3 to the right 1. Okay, my y-intercept. Well, I don't have anything on my y-intercept right here, do I? This is like plus 0. Okay, so that is a little confusing, but there is still something there. It's just a 0, plus 0. So my y-intercept is going to be 0. This is my starting point. So what I'm going to do is go to my graph. I'm going to start at 0, and then I'm going to do what my slope says. I go up 1, 2, 3, and to the right 1. So I started at 0, 0, and then I went up 3 to the right 1.
And that's a start at 0, you said?
Start at 0. Yeah, start at 0, 0. Yeah, that says start here. The next one, very similar. I have y equals negative 2x. So when I'm looking at the y equals mx plus b, it's always nice to like write y equals mx plus b right underneath it because then you get to see exactly where things go. So like the negative. Yeah, no, you're good. Yeah. So my slope here is the number in front of x, so negative 2. Again, I'm going to write negative 2/1. This time it's negative, so since it's negative, I'm going to go down 2 to the right 1. And so we're on the same topic here, so my slope, or my y-intercept is going to be 0 when there's nothing past the negative x, or the number in the x. Your slope is 0. I'm sorry, your y-intercept is 0. So I start at 0, 0, and then I do what my slope says. My slope says I go down 2 to the right 1. So I start at 0, 0. I go down 2 to the right 1. You only need 2 points to make a graph. Okay, you only need 2 points to make a graph, or make a line graph. But every time I think about doing these, find the m, find the b, find the slope, find the y-intercept. All right, so moving on to ones with an actual y-intercept. Y equals 2x plus 1. Again, I'm just going to write mx plus b underneath just to like see it easily. But on this one, my slope is 2. That's the number in front of x. So 2/1. So since it's positive, I'm going to go up 2 to the right 1. And my y-intercept is going to be 1 this time. Okay, so you see the b and the 1. And that is going to be my starting location. Anytime we interpret this in like real life scenarios, we start at 1 and then you move up, you're increasing or you're decreasing as it moves to the right. All right, so we started at 1 and then we go up 2 to the right 1. So we started at 0, 1, and then we went up 2 to the right 1. We went up because it's positive, to the right 1 because my denominator is 1. Always go to the right. Good. All right, on this one, y equals mx plus b. So my slope is -3 this time. That'd be -3/1. So I go down 3 to the right 1. And my y-intercept is the one that's by itself, the 4. So I start at 4, and then I go down 3 to the right 1. Down 1, 2, 3 to the right 1. I started at 0, 4, and I went down 3 to the right 1. Oh, sorry. All right, next topic. So this one, we are actually going to have fractions in our slope instead of just whole numbers that we put over 1. But everything's going to work the same way. So my slope is the number in front of x, so it's 1/2. So it's positive, so I go up 1, and I'm going to go to the right 2. And then my y-intercept is -3. So that is my starting location. So I start at -3, and then I go up 1 to the right 2. So I started at -3, and then I went up 1 to the right 2. By the way, we hadn't said this yet, but this is like the rate of change of the line, and it never changes. Like no matter where I'm at on this line, if I always go up 1 to the right 2, I'll land back on the line. Up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. It always will work like that. Oops. The next one, same idea here. It's already in y equals mx plus b. So we're going to do our y equals mx plus b. Our m is -3/4. So I'm going to go down 3 because it's negative and to the right 4. Notice at the bottom, on the number on the bottom, never changes. Always go to the right. The positive is, or the top number changes because if it's positive, you go up. If it's negative, you go down. But the bottom number always tells you to go to the right. My y-intercept is 2. So I start at 2, and then I'm going to go down 1, 2, 3 to the right 4. I started at 2 and went down 3 to the right 4. All right, the next one, we've been doing y equals mx plus b on all these. This is back in that standard form, that ax plus by equals c. So what we want to do, I told you, we want to find the m, we want to find the b, find the y or the slope and the y-intercept. So I want to solve for y. Okay, so we got to do a little bit of algebra on here. I got to solve for y. I got to get the y by itself. Okay, so what I'm going to do is I'm going to get rid of anything that's bugging the y. I'm going to subtract 2x. So I get y equals negative 2x plus 4. Now, just by moving that one, I now have it in the form y equals mx plus b. And we're good. You do not combine the 2 and the 4, the negative 2 and the 4, because the negative 2 has an x with it and the 4 does not. Okay. So just like we were doing now, my slope is negative 2, which is negative 2 over 1. And my y-intercept, so that means what? It's negative, so down 2 to the right 1. And my y-intercept is 4. So I'm going to start at 4, and then I go down 2 to the right 1. Start at 4, down 2 to the right 1. All right, next one, same topic as the last one, so we need to get y by itself. So what I'm going to do first is get rid of the 3x by subtracting 3x from both sides. Again, do not combine the negative 3 and the 6 because the negative 3 has an x and the 6 doesn't. But then to get y completely by itself, that negative 2 is bugging it. So I need to divide by negative 2. When you divide by negative 2, you need to divide everything in here by negative 2. So negative 3 divided by negative 2, negative divided by negative would be positive. You just leave that as a fraction. We're doing rise over run, so a fraction there is fine. And then 6 divided by negative 2 would be negative 3. So divide everything by negative 2. So now my slope is 3/2, which means I go up 3 to the right 2. And my y-intercept is negative 3. So I start at negative 3, and then I go up 3 to the right 2. So when a problem is not in... Start at negative 3, up 3 to the right 2. When a problem is not in that y equals mx plus b form, you may have to do some manipulations in algebra, but we always want to think to be able to graph, even to be able to write system of equations or write equations or anything like that. You always do y equals mx plus b. You want to find the m, you want to find the b. Okay, so make it to where you can find the m and the b. Don't just take this m, right? That's not my m. The 3 is not my m. I had to put it in y equals mx plus b first before I try to find my m and find my b. All right, 2 different ones here, or odd ones out. I'll give you a second to write it, but x equal any number. If x equals any number, it is always going to be a vertical line. Go ahead and graph this so you can see it. But what I would think about here, the way I remember it, is if I go to x equals 3, which is what this one is, x equals 3, that's where x equals 3 right there, right? It doesn't really make sense to draw it this way. I should know it's a weird one just because it looks different, because it's x equals a number. So it is going to be a vertical line. And the way my brain does it is it doesn't matter what y is, x is always going to be 3. Okay, so if y is 10, x is 3. If y is negative 10, x is 3. No matter what y is, x is always going to stay at 3. Okay. There is no y-intercept on this one because it doesn't cross the y-axis. but the slope is undefined. The reason the slope is undefined is because this graph is always going up or down. It's never going to the right. So this would be like, this is just an example, but this would be like if you did 2 divided by 0. You can't divide by 0, right? If you do that in a calculator, you get undefined. So this would be like going up 2 into the right 0. If I go up 2 into the right 0, I'd never move. Up 2, up 2, up 2, up 2. I never go to the right. So that creates the vertical line, and that is why it's called undefined, because you divide by 0 on all these. If it's y equals a number, it is a horizontal line. And again, just like we did last time, if you go to y equals -2, y equals -2, and you put your dot there, it doesn't really make sense to draw it this way. It's going to work a lot better if you draw it horizontally. But same idea, it doesn't matter what x is. No matter what x is, y is always going to be -2. Okay, so if x is 10, y is -2. If x is -10, y is -2. No matter what x is, y is always -2 because y equals -2. The one other way you can write this out too is if you have y equals -2, you could say y equals 0x minus 2. That's a little harder to think about, but my y-intercept is going to be whatever number it is there, right? If y equals 10, then my y-intercept is going to be 10. Here it's y equals -2, so my y-intercept is -2. My slope on this one is 0, because on this one I never go up or down, I always go to the right, okay? So 0 divided by any number is always going to be 0. If I go up 0, then move 3 to the right, up 0, 3 to the right, up 0, 3 to the right, it creates a horizontal. All right, this one I had to draw a picture, and it doesn't work the best when you have to draw this by hand. I was going to take the picture from Alex, but I forgot. This one, they're going to give you a graph, and you're going to pick one or find the slope from this, okay? They give them the graph, you find the slope. So I put a couple tips here on the right-hand side, but you always start on the left. I said this at the very beginning. We read from left to right, so you always want to start on these on the left. So you find the point on the left, okay? Find the point on the left. The point on the left here is 0, 2, and we don't have to do anything with that, I guess, really. We're just going to count. So what I'm going to do is I'm going to look at this. I'm going to start on this point right here, and then I'm going to work up or down. So this is step number 2. Once I start on the left, I'm going to work up or down to be even with my other point. So on this one, I'm going to go down 2. So I went down 2. And then I'm going to go to the right, 1, 2, 3, 4. So if you work up, it's going to be positive. If you work down, it's going to be negative. And then you work towards the right to get exactly to that point. So we can divide this by 2, which would be -1/2. And that would be my answer. That means we actually could have just went down 1 to the right 2, and we would have ended up on the line as well. I'm pretty sure Alex is pretty good about if you input like -2/4, they'll probably say, your answer is correct, but please reduce it. Not just count it wrong. So it's not like doing a fractions topic. We're talking about graphing, so it's usually nice to you on that. But on this, always start on the left, find a point, find the point work to the one on the right, whether it's going up or down, and then go to the right. All right, the next one is finding the x and y intercepts. Yeah, go back up for a second. Yeah. Oh. All right, the last few topics are about the x and y intercepts. So the x-intercept is where it crosses the x-axis. The y-intercept is where it crosses the y-axis. We've already talked a little bit about the y-intercept because that's our b in the y equals mx plus b. I actually said this at the very beginning, but the y-intercept, algebraically, to find the y-intercept, you make x be 0 because that's our starting point. So we have it as x equals 0. So to find the y-intercept, you make x be 0. To find the x-intercept, you make y be 0. Okay? So in this equation right here, Honestly, these are in y equals mx plus b right now, so we don't even have to solve this, but since we're doing it, I'm going to write it out to make sure we see it. What I'm going to do is make x be 0. So 2 times 0 goes away, and I just have y equals 3. So my y-intercept is 0, 3. When it's in y equals mx plus b, the x-intercept's a little harder to find usually, but not terrible. So on the x-intercept, we make y be 0. So I put a 0 in for my y, and I'm going to solve for x. So to get x by itself, I'm going to subtract 3 to both sides, and then divide by 2. So negative 3 halves equals x. So my x-intercept is negative 3 halves and 0. Which is fine. We don't have to graph this, so it's fine if there's a fraction. The next one, same idea. We're going to find the y-intercept, we make x be 0. You have a negative 0 there, but that's fine. So you get y equals negative 1. Again, the 0 minus 1 would just be negative 1. So you have 0, negative 1, and that's my y-intercept. To find the x-intercept, you make 0 be your y. This one's a little trickier. So to solve for x, I add 1 to both sides, and then divide by negative 1. So sorry, I just should talk about that more for a second. There is a negative in front of the x right here. Since there's a negative in front of the x, that's like a negative 1. I got to get rid of that negative for that x to be all by itself. So you divide by negative 1. So 1 divided by negative 1 would be negative 1. So this would be at negative 1, 0. All right, the next topic is actually graphing a line, just given its x and y intercepts. Like I said earlier, you need 2 points to graph a line. If you have 2 points, then you can connect a line to them. So on this one, it's super easy. Your x-intercept is 2, 0, and your y-intercept is 0, 4. So that's where it crosses the x-axis, where it crosses the y-axis, and then I can graph my line. Graphing these, when they just flat out give you the intercepts, it's easier than doing y equals mx plus b. But when you actually have to solve the intercepts and then graph it, it takes longer. I think it's easier just to put it in y equals mx plus b. But the x-intercept where it crosses the x-axis, the y-intercept where it crosses the y-axis. Some of these things, like I used a finance example earlier, but when you have like financial graphs and equations, like this is kind of like it could be a break-even point, or it could be a uh-oh point because we're losing profit, and you're going to start losing money, that kind of thing. On this one, it's negative 3, 0, so I go to negative 3, and then y-intercept is 0, 1. But these should be pretty easy for y'all to get through on Alex. I guess I could write this real quick. Negative 3, 0, 0, 1. Sorry, I'll go back down in just a second. The x-intercepts are like, I was trying to think of some other examples in just finance, like a projectile. If I throw a football in the air, like when it starts here, but when it actually hits the ground would be an x-intercept, like where it hits, how far it would go and how fast it's traveling and different things like that. That's when it would hit the x-axis. That would be an x-intercept. It's how they measure how far home runs are supposed to go and things like that. All right, so graphing a line by first finding its x and y intercept. So the first thing I want to do on these is find my y-intercept. So to find the y-intercept, we make x be 0. These questions are a little tougher. They're in that standard form. So I put a 0 in for my x. and I'm going to solve for y. So this cancels out because it's just 0. 0 times 2 is 0. So I divide by 3, and y equals 2. So 0, 2 is my y-intercept. My x-intercept is going to have a very similar setup. To find my x-intercept, I put a 0 in for my y. It's always the opposite. To find the y-intercept, you put a 0 in for x. To find the x-intercept, you put a 0 in for y. So again, 3 times 0 just goes to 0, so you just have 2x equals 6, divide by 2, and x equals 3. I don't have my graph on this one. No. Copy that for my next one. Okay, so to graph these, I go to my y-intercept is 0, 2, my x-intercept is 0, 3. So y-intercept is 0, 2, x-intercept is 0, 3, or 3, 0, I'm sorry, 3, 0, and then I can graph it. So 0, 2, 3, 0.
Could you go back up for a second?
All right, same thing on the next one. To find the y-intercept, I make x be 0. And then I just have negative y equals 4. That is like a negative 1, so I want to divide by negative 1. Get y equals negative 4. So my y-axis is at 0, negative 4. I'm sorry, my y-intercept. And then to find my x-intercept, I make y be 0. So I plug a 0 in for my y. X minus 0 would just be x. So this one is at 4, 0. So I plot my y-intercept at 0, negative 4. Plot my x-intercept at 4, 0. And then I can make my line. So y was 0, negative 4, and this one is 4, 0. And then the last topic here is finding the x and y-intercept again, but it's from the standard form, so it's a little tougher. But same idea. When you have the y-intercept, we want to make x be 0. So 4 times 0 minus 5y equals 10. Again, this 4 times 0 goes away, so I just need to divide by negative 5. So I get y equals negative 2. And then on the other one, to find the x-intercept, I make y be 0. So negative 5 times 0 goes away, and I have 4x equals 10. Divide both sides by 4. And I get 10 fourths. If you divide those both by 2, you get 5 halves. Again, I'm pretty sure Alex will give you a warning if you accidentally put in 10 fourths. Or maybe even count it right and say, hey, it's right, but you can reduce it. Y'all can let me know if I'm wrong. And then the last problem is the same one of those. Very similar. It's just got some more negatives in it. Why isn't that? So negative 2x plus 3y equals negative 9. To find the y-intercept, I want to make x be 0. So negative 2 times 0 goes away, so we can just divide by 3. So y equals negative 3. And then to find the x-intercept, I make y be 0. Three times 0 goes away. Divide by negative 2, and x equals 9/2.